Students have come to the next stage for type 2, clarity of differential px plus qy plus f of p comma q is equal to 0. This type, if you substitute p and b for q, the complementary of this type dy plus f of a comma b. So this no need for further number of is equal to the number of arbitrary constants here. As in the previous form, we need not find out a substitution for. We have 3 arbitrary c. So for b we are substitution in terms of a. Here the to ax plus by plus f of b. So our duty is to find the singular solution, or z is qy plus p squared plus pq plus q squared. The form now of the equation z is equal to px plus qy plus p squared plus pq. You have to look into the equation. This is of the or type px plus qy plus f p comma q, and you are due to the q b, replace p by a and q by b. Now the complementary integral you can arrive. Z is equal to ax plus by plus a squared plus ab plus b squared is the complementary integral. To find the singular integral, you have to differentiate the equation number 1 with respect to a and b and equate them to substitution for a. Finally, you can arrive the singular integral. If the Clairaut's form is given, you just replace p by a and q by b, you can get the complementary integral. And after arriving the complementary integral, you need to differentiate the integral with a and b and equate them to 0. Find a substitution for a and comma y. Now the complement 1 with respect to a and equate it to 0, we get, you look into the equation number 1, the right hand side, the first term is ax. We are now differentiating with respect to a. X is a constant, differentiation of a is 1 here. In the second term, by has come. Now we are differentiating with respect to a. B is treated as a constant, y is treated as a constant, so the differentiation of by is equal to 0. The third term is a squared, the differentiation of a squared is 2a. The fourth term is ab, b is treated as a constant, the differentiation of a is 1. And the fifth term is b squared is treated as a constant, the differentiation of a constant is equal to 0. So dou z by dou a is x plus 2a plus b, and equate this to 0. X plus 2a plus b equal to 0, let this be equation number 2. And you find out dou z by dou b. The equation number 1, the first term is ax. We are now differentiating with respect to b. A is treated as a constant, x is treated as a constant, the differentiation of the first term is 0. B has come, y constant, the differentiation of b with respect to b is 1. Y, so there has been written y. And the third term, a squared has come, the differentiation of a squared is 0 because a squared is treated as a constant. In the fourth term, ab has come. We are now differentiating with respect to b. A is treated as a constant and the differentiation of b with respect to a there. And the fifth term, b squared, with respect to b is 2b. Now our duty is to a and b and y. From 2 we can get a substitution for a. You move the x term and b term to the right hand side, they will become minus of x plus b. At the left hand side 2a will be there, and move the 2 to the right hand side. So from 2 we can get a is equal to minus of x plus b divided by 2. Let this be equation number 4. You substitute 4, you look into the equation number 3. If you substitute for a in 3 we can get a substitution for b in terms of x and y. For 3, first term is y, second term is a. For a you are substituting x minus of x plus b divided by 2 plus 2b. From this, y minus divided by 2 x and b, minus x by 2 minus b by 2, y minus x by 2, and subtracted from 2b, it is 3 by 2b is equal to 0. Now keeping 3 by 2 on the left hand side, you move the other terms, become x by 2 minus y. Therefore b is equal to x minus 2y divided by 3. X minus 2y divided by 3. So taking LCM and moving the terms to the right hand side, we have arrived b is equal to x minus 2y, and substitute 5 in 4. Substitute 5 in 4, and substituting 5, equation number 5, and look at the equation number 4. The equation number 4 is having the term b, it is to be eliminated. So a is equal to minus 1 by 2, x is written as it is. Instead of b, we are substituting x minus 2y by 3, and taking LCM, the term is becoming minus of 4x minus 2y divided by 6, and dividing by 2 the numerator and the denominator, we are getting y minus 2x by 3, the minus is this is, let this be equation number 6. Now we have arrived a substitution for b. b is equal to x minus 2y by 3. This is equation number 5. A is equal to y minus 2x divided by 3. This is equation number 6. So these two equations are to be substituted in equation number 1. You rewrite the equation number 1 from the previous page. One is z is equal to ax plus by plus a squared plus ab plus b squared. In this equation number 1, substitute 5 and 6. Z is equal to, first term is ax. For a you can substitute y minus 2x by 3 into x. Second term is by. For b you can substitute x minus 2y by 3 into y. And the third term is a squared. A is y minus 2x divided by 3. A squared, it is whole squared. And the fourth term is ab. A is y minus 2x divided by 3, and b is x minus 2y divided by 3. And the squared, for b squared, x minus 2y divided by 3 the whole square. Now you have to be very careful and you have to keep patience while solve this problem, because it is a lengthier equation. So reducing this equation, it is a tough task. Now you multiply, in the first term you multiply x inside, xy minus 2x squared divided by 3. In the second term you multiply by y inside, it is xy minus 2y squared divided by 3. In the third term, it is numerator is a minus b the whole square, and you use the formula a minus b whole square. A squared minus 2ab plus b squared. So y squared plus 4x squared minus 4xy divided by 9. The denominator is to be squared also here. And the fourth term, the denominator is 9, and multiplying the numerator we get xy minus 2x squared minus 2y squared plus 4xy. And the fifth term, it is also a minus b whole squared in the numerator. Denominator 3 squared is 9, and expand by a minus b whole squared, the numerator, it is x squared plus 4y squared minus 4xy. And taking LCM throughout, LCM is 9, and we are getting the numerator as given in this problem. And you have to, there are three terms here. One is x squared term, another one is y squared term, another one is xy term. You add the algebraic sum of xy, algebraic sum of x squared, algebraic sum of y squared, and finally we get z is equal to 3xy minus 3x squared minus 3y squared divided by 9. dividing the numerator and denominator by 3 and cross multiplying, we get the final equation as 3z is equal to xy minus x squared minus y squared. Even though it might be a lengthier problem, and if you adopt the simplest fundamental principles, you can easily solve the problem without any mistake. Px plus qy plus q by p minus p. This is of the type z is equal to px plus qy plus f of p comma q, Clairaut's form. In Clairaut's form, to get the complete integral, replace p by a and q by b. That is, z is equal to ax plus by plus b by a minus a is the complementary integral. We know that an expression which is having the number of arbitrary constants is equal to the number of independent variables is the complete integral. You look into this equation, z is equal to ax plus by plus b by a minus a. X and y are the independent variables, a and b are the arbitrary constants. So the number of independent variables are equal to the number of arbitrary constants. So z is equal to ax plus by plus b by a minus a is taken as the complementary integral for the given problem or given expression. Now our duty is to find out the singular integral. To find the singular integral, let you differentiate the equation number 1 with respect to a and equate it to 0, and from 1 you find out dou z by dou a and equate it to 0. We get, you look into the equation number 1, at the right hand side the first term is ax, x is treated as a constant, the differentiation of a is 1. The second term is by, b is treated as a constant, y is treated as a constant. Since here we are differentiating with respect to a, the differentiation of the second term is 0. And in the third term, b is a constant and differentiation of 1 by a is minus of 1 by a square. And the final term is a, differentiation of minus a is minus 1. This is taken as equation number 2. Now you also find out dou z by dou b, dou z by dou b, which is equal to 0, equal to 0. You again look into the equation number 1. At the right hand side, the first term is a into x. We are now differentiating with respect to b. So the differentiation of the first term is 0 because it is a constant. A is treated as a constant, x is treated as a constant. The second term, by, we are now differentiating with respect to b. Y is a constant, the differentiation of b is 1. In the third term, we are now differentiating with respect to b. 1 by a is a constant, the differentiation of b is 1. Let you take this as equation number 3, and from 3 we can get this is equated to 0, this is also equated to 0. 1 by a is equal to minus y, so a is equal to minus of 1 by y. A is equal to minus of 1 by y. Now let you take this as equation number 4. Substitute 4 in 2. Now you have to stop a little while and you have to think. A is having y term only, so we have got a substitution for a, and we haven't got a substitution for b. And if you substitute a in equation number 2, you can get b in terms of x and y. You have to think a little while and substitute 4 in 2. We get 0 equal to x is taken as it is minus b divided by a squared is 1 by y squared, 1 by y squared minus 1, and this will become x minus by squared, x minus by squared minus 1 is equal to 0. Now you move the term by squared to the other side. By squared will be equal to x minus 1, x minus 1, and from this we can find the value for b in terms of x and y as x minus b is equal to x minus 1 divided by y squared, divided by y squared. Now let you take this equation number 5. Now you substitute 4 and 5 because we have got a substitution for a in terms of y, and we have got a substitution for b in terms of x and y. Our purpose is to eliminate a and b from the complementary integral to get the singular integral. Our purpose is to eliminate a and b from the complete integral to obtain the single integral. So substitute 4 and 5, 4 and 5 in 1. That is z is equal to, you look into the equation number 1, first term is ax. For ax you can substitute 1 by y into x, and the second term is by. For b you can substitute x minus 1 divided by y squared into y. The third term is b by a. The third term is b by a. b is x minus 1 by y squared and a is minus of 1 by y, and the final term is minus a, so it is, you can substitute minus of 1 by y. And rearranging the equations, minus x by y, and in this y cancelled, and this will become plus 1 divided by y, and in this term this y will get cancelled with square, and in this term it is minus of x minus 1 divided by y, and this is minus of minus will become plus 1 by y, and all the terms are having y, and taking LCM as y. This is minus x, this is plus x minus 1 minus x plus 1 divided by y, and this minus x and plus x gets cancelled, this plus 1 and minus 1 gets cancelled, so the remaining term is 1 minus x divided by y. 1 minus x is divided by y, and you move this y to the left hand side, so the final equation becomes zy or yz is equal to 1 minus x. So this is the singular integral.